Hello and welcome to Accelerate Revit's CAD Data Sharing with Riverbed Steelhead Technology. So with that, I'll turn the session over to Mark Schleicher. Mark, please go ahead.
Thank you, and I appreciate everyone's time this afternoon. We're all really here to learn how we can utilize the talent we have in our remote offices, how we can consolidate data to a central data center and yet not affect performance for those remote users when trying to access that data. I've been involved with Riverbed now for going on 11 years. I still say that Riverbed is the best solution for AEC firms who are trying to figure out how to utilize our remote office personnel as if they're all sitting in one office. We've seen a lot of competitors over the years. Today we see a lot of marketing material coming out of Panzer. 3 years ago we saw a lot of marketing material coming from Silver Peak. 3 years before that it was Cisco. We don't see Cisco or Silver Peak much anymore in this space. The one constant has been Riverbed is the industry leader and continues to be the industry leader and continues to improve the Steelhead technology. And now with the introduction of SteelFusion, we've got a truly unique solution that isn't offered by any of our competitors. So my presentation today is broken into 3 different stages. Stage 1 will be a discussion about WAN acceleration, how we negate the effects of latency and allow our remote users in remote offices or working in construction trailers or home offices, how we can incorporate all of those people into our projects without moving data closer to the users or moving users closer to the data. The second piece of the presentation will be a live demonstration. I'll use both AutoCAD and Revit. I'll open an AutoCAD file and a Revit model over a VPN connection. We'll time that, and you'll gauge the time it takes me to open that over a VPN connection accelerated with the Steelhead technology. And then we'll do the same, but open it from my local C drive so you can see what kind of speed you can anticipate getting utilizing the Steelheads. The third part of the presentation is what we've coined 21st century networking. This is the introduction of Riverbed SteelFusion, and I'll offer some specific use cases for how to implement this in the AEC space. I'll talk lastly about a proof of concept program that allows you to see this functioning on your own network. Even though this demo is live today, I've done this 1,000 times, so I pretty much know what's going to happen here, or hopefully, knock wood. But seeing this on your own network really would be the proof that you would need in order to be comfortable with the technology and how it functions. We've allotted an hour of time. My presentation will take approximately 30 minutes, so we'll have plenty of time at the end to address any questions that you might have. So starting at the beginning, and I know we've probably got some people that have seen this piece of my presentation before. Bear with me, please. When we get to the SteelFusion part, we've got something really new and unique for you to see. But for those that haven't experienced this presentation before, here's been the problem that we've all experienced when trying to centrally store our project data, particularly our CAD files, because CAD files are so much larger than a Word document or an Excel file. But when we try to centrally store those CAD files and allow our remote office teams to go across whatever connection that we may have and access that data, kind of how slowly that red dot's moving across the screen was the experience that those users would get. Now we assumed that this was an issue of not having enough bandwidth because, as we know, the more bandwidth we have, the faster we can browse the internet and the faster the pages load. In wide area networking, bandwidth speaks more to capacity than it does speed. So a T1 line will work exceptional for 2 people and it'll be horrible for 20. So an example that I like to give when thinking about latency, that round trip time, and bandwidth would be, consider the time it takes you to get to your local airport. Say it takes you 30 minutes to get there. your latency or your round trip time to the airport is 1 hour, 30 minutes there, 30 minutes back. The equivalent of adding bandwidth to that example would be like adding another lane to the highway that gets you to and from the airport. What you've done by doing that is increase the capacity of cars that can make that trip, but you've not moved the airport any closer to you. You're still subject to that latency. And in wide area network and in sharing our CAD files, latency is the problem, and we're addressing latency with the Steelhead WAN acceleration solution from Riverbed. So graphically, what happens when a branch office user goes across whatever connection you have? Incidentally, we're seeing a lot of companies moving to VPN connections and away from MPLS connections today, just because of the availability of more bandwidth for less money. But it doesn't matter to us if it's a private line or if it's a VPN connection, we'll function the same. But getting back to that user who goes across that connection and selects a CAD file here at our data center, what happens is when you hit open, that file gets broken down into individual packets and delivered in sequential order, one at a time across that connection. And kind of like the old CB radio days, only one side can be talking at any one point. So the server may say, okay, here's this packet. It won't send another packet until receiving acknowledgement back from the client. That's what we refer to as chatter. So the speed of this is subject to the latency on that line. The further apart those offices are, the higher the latency, the longer this process will take. So we're going to address latency with the implementation of the Steelhead technology from Riverbed. In this instance, I'm demonstrating here a physical Steelhead appliance that gets installed on both ends of that connection. We install these in path, meaning between your router and your switch. If you've got a firewall here, we're behind your firewall. So we make no changes to your security. We don't touch your servers or anything like that. We simply set in path, and any data that's flowing across that connection has to go through our Steelhead appliances. Optimization can only occur when there is Steelhead technology on both ends of that connection. So what happens is we do three things to your data. The first thing we do is apply some compression. So being limited to that 64K packet, we can expand that and deliver up to a full 1 meg with each round trip, thereby eliminating a number of round trips required in order to deliver that file quicker to the other side. The big thing that we do is this process called scalable data referencing. This is a proprietary algorithm owned by Riverbed, and it's a process of deduplication. It's very important to note that we don't cache your files on these Steelhead appliances. What we are doing, however, is looking at the binary information when that traffic flows across that connection, and we're replacing your data with pointers. We look at the ones and zeros. So a wall, door, or a window to us would look like we would replace that with a pointer. And the next time we saw that same element or same wall, door, or window, we would just send a pointer across that slow connection and then rebuild that data based on the pointer that's stored on the Steelhead appliance on the other side. So what happens here, the general effect of this is you will start to see between 90–95% reduction in the amount of physical traffic that has to go across that slow connection in order to recreate your data and deliver it on the high-speed LAN section to the user. The third thing we do is a process of transaction prediction. Essentially what we're doing here is a series of proxy moves. So the Steelhead on the client side will pose as the client. The Steelhead on the server side will kind of pose as the server and communicate directly with each other to speed that process of getting that information over to the other side, again, so we can deliver it on the high-speed LAN section over here on the remote office side. So those are the three things that the Steelhead appliances are doing, or the Steelhead technology is doing. So I want to take a minute and talk about our traditional collaboration workflow, what we call the old file-centric workflow or our AutoCAD workflow. So back in the day, we would have our data center here, or our home office. We would have our local users here accessing data off the LAN, and the speed, of course, was great because the servers were right there. As we saw on that first screen, when we tried to start using remote office people in our projects, trying to get them to share that data when we stored it here at the data center was simply non-productive and very frustrating for those users. So we had a choice to make. We either could move those people closer to the data or move the data out closer to the people. And typically we chose the latter. For our remote offices, we would put storage out here, we would have backup systems out here, and we would ask our IT staff now to support several LANs for each remote office that we had. And we would have to take copies of our project data and move it out here to this storage so that these users had LAN speed access to that data as well. When we started working with consultants or people out in the field or working at home offices or construction trailers, now we had all these different AutoCAD clients out here that we needed to find a way to share this work with. So we turned to these collaboration portals, a project-based FTP site, or Buzzsaw from Autodesk, which is A360 now. But essentially what we'd do is take our project data and we would move it out to that collaboration portal and allow our project team access to that portal where they would go and download that information to a local server or on their workstation and start their work on their individual AutoCAD files. At certain intervals, we would ask them to repost that data back up here to the portal. Somebody from the owner's side would go and grab that information, pull it back in-house, and start checking all of the files and XREFing everything back together, and then repost it back out there on the portal so that we all could download it again and continue on our process of our design. Revit changed this whole thing here. With Revit now, we had to find a way for our dispersed project teams, multiple people in multiple offices, to be able to access a single Revit model stored here at the data center, what we call true collaboration. And in the same workflow, true collaboration can exist with the implementation of the Riverbed Steelhead WAN accelerator technology. So because now we've addressed latency with the implementation of the Steelheads, we no longer need that storage out here at these remote offices. We no longer need to rely upon those project-based FTP sites in order to deliver our information to those users. For our individual onesie-twosie users out there like me, people with laptops who travel or out in the field, we utilize Steelhead Mobile, which is a software client. We call it Steelhead for One. So whether you've got Steelhead Mobile on your laptop or you're sitting in an office behind a Steelhead appliance, you can get the same kind of acceleration to that project data that's centrally stored here in our corporate office or our main office. So we're providing that accelerated optimization to that Revit model or whatever that project data is. We've not changed anything here for the LAN users. Really what we're trying to do is take our LAN-based workflow and extend that out to our WAN users regardless of where they're physically located, and allow everyone to work on this project data as if they're sitting in one office together. So let me turn now and do a live demonstration for you. So I'm going to be this user here. I've got a laptop with Steelhead Mobile. I'll show you the Steelhead Mobile software. This is just a software client that I have on my laptop. Whenever I connect to my VPN, this mobile client starts, and so long as there's a Steelhead on the other end of that connection, I'll peer to it and start getting optimization automatically. So I'm going to be this user here, going over a VPN connection, accessing files on a server that's approximately 90 miles away from me, and I'll do both AutoCAD and Revit, and we'll record the times and you'll see. So let's start with AutoCAD. AutoCAD 2016. Let's go into my iDrive, which is my VPN, my internet. Here's the file that we want to open. Properties on this, it's 9.53 meg. And let's go ahead and just open this AutoCAD file across the wire. I'm not going to time this because it does so fast that it's difficult to get an accurate time, but you'll see on the eye test here how quick that was. Let's close that then, and now let's open the same file but from my C drive. So we'll go here to our CAD files, here's the same file, and we'll go ahead and open that locally. Not even from a local server, but from my C drive. So if we would have timed that, we would have seen maybe a second or less than a second difference on a 9.5 meg AutoCAD file. And this is the kind of performance that you can expect for accessing data across that VPN connection when it's accelerated with the Steelhead technology. Let's move now to Revit. Same thing. I will time this one for you though. I'll get my timer ready. And again, I'm going to go to my iDrive, and I'm going to select this Revit 2016 model, and I'll show you the size of this as well, 114 meg. Not super huge, but gives us a nice little test, and we'll go ahead and open that. So you notice that I didn't make any changes to how your users would normally use Revit. Typically, this opens for me in about 50 seconds, so I've got this timed for you, but I've got an HP laptop here, 8 gig of memory, a little undersized for Revit 2016, but still offers us a very good test and a good showing on how Revit performs across a VPN connection. I've done live demos at the national AIA shows, and we're at Autodesk University every year, and we do live demos there traditionally, and I've gotten similar speeds as what I'm showing you here, regardless of where I'm physically located. So we're nearly complete now. We're at 45 seconds right now, and almost done. And that was 52 seconds to open that over the VPN. Even though I've not made any changes, I do want to show you a sync to central and time that for you, just because even though we've not made any changes, when you do a sync to central, of course, Revit still has to compare the local working copy with the server, and that does take a certain amount of time. Generally, this is done within about 30 seconds for me. We're at 15 seconds now. So when this comes up, we'll open that same file from the C drive, and we're nearly complete here, done at 31 seconds. So let me go ahead and close this. I'll go ahead and save that. And now let's go and open that from the C drive. And I'll go here to my Revit folder. Same model. And it took us about, I didn't write, it was 52 seconds to open that over the VPN connection. And we should be opened here right around 30 seconds or so locally from my C drive. Again, it's from the C drive and not a local server. So typically when you're working on a project with others, of course, it would be on a network drive, naturally. Nearly complete and done at 29 seconds. So I'll go ahead and close here. And jump back into the presentation. So we've reached the third part of the presentation, which we like to refer to as 21st century networking. This is the introduction of Riverbed SteelFusion. SteelFusion is zero branch IT, meaning no storage, no backup. So I want to first just explain the modules that make up SteelFusion. There are two. SteelFusion Core at your data center and SteelFusion Edge at the remote office. Keep in mind, SteelFusion Edge includes all of the functionality of Steelhead WAN acceleration built in. SteelFusion Core allows you to do additional things beyond WAN acceleration and I'll show you those two things now. The things that it allows you to do is from your data center, allows you to create the VMs here at your data center. In this case, we're showing a virtual Windows server. And through SteelFusion Core, you can take that server and project that out to the SteelFusion Edge partition and boot that server over the internet. So the server is actually running here on the SteelFusion Edge module. The other thing that you can do with SteelFusion is take that office's data, create that as a data LUN, and pin that data out to the SteelFusion Edge partition. The advantage of doing this is that SteelFusion Core is constantly monitoring any changes that we're making out here at the remote side, pulling those changes across and centrally storing it on our corporate SAN. So we're managing all of our VMs and we're managing all of our data from the data center. If this WAN link goes down, the data exists out here in a virtual format, meaning these users continue to work as if nothing ever happened, because for them, nothing has happened. When that connection comes back up, SteelFusion Core will then reconnect with SteelFusion Edge and pull any changes that it's made back to the corporate SAN. So practical use cases in the AEC world for SteelFusion. Well, first of all, I want to say that SteelFusion does not have to be implemented corporate-wide. You may find that there's definitive need to be able to manage and push out all of your VMs, your servers, your new Forma servers, for example, put those out here at the edge and boot those servers so that if you ever need to recreate a server or do work on a server, you do that work here at your data center, and then you just repin that operating system or that server back out at SteelFusion Edge and boot that over the wire. So you have the benefit of that local server out here for print queues and for global catalogs for our CAD products and all that. SteelFusion Edge can provide you with that. Another thing that is becoming increasingly of interest is the idea about moving the data center to the cloud. So if you've got a local cloud provider that you're thinking of, you could rent a rack or half a rack in that cloud provider, put a server or some storage up there, put SteelFusion Core in the cloud provider. Here then would be your data center over here on the left, and you would be able to take all of your data, move it to the cloud, yet project it back to your data center where all of your users would be able to access it. The advantage in doing that is you allow the cloud provider to do all of your backup for you, and you allow the cloud provider to provide replication to its other sites for disaster recovery. Some more use cases for SteelFusion Edge. I talked in the first part of the presentation about consolidating your data back to the data center. Now I've kind of switched gears and I'm talking about projecting data back out. Well, why? What are the use cases in doing so? You may find that you've got an office that does predominantly GIS. GIS data is massive, what with the aerial photographs and satellite images. It might make sense for you to project that data back out to SteelFusion Edge for the GIS users in a particular office. Keep in mind, all of that data is centrally stored and managed here at the data center, so you'll have one place to do your tape backup here at the data center. Another use case might be for marketing data. So if you've got a marketing team that's out in a remote office and they're the only ones that access that data, it might make sense for you to project that LUN of marketing data out to those users in that remote office. Here's another use case. Let's say that we've got our corporate offices in Atlanta, and let's say that this office here is in Denver. Denver is our major Western hub office where we have a couple hundred people in this office. But Denver also is the hub for a few satellite offices on the West Coast. Here would be another use case for SteelFusion Edge. We would take all of Denver's data and we would project it out to them so the Denver users are accessing that data locally. But for those satellite offices on the West Coast, let's say we've got an office of 5 people here in Seattle. We can utilize the Steelhead WAN acceleration for the Seattle office to access data in Denver. Well, how do we do that? We've already told you that here in Denver we've got that virtual server and we've got their LUN of data here in Denver. Well, that LUN of data is presented to the users as a simple Windows share. It's a drive letter. So all we have to do for these users in Seattle is map that drive letter to them, and now they have access to the data in Denver, and through WAN acceleration they can get that accelerated access and utilize all of the data here in Denver. Keep in mind, any changes that are being done to this data in Denver, regardless of where the users are who are accessing that, that data is pulled across the wire by SteelFusion Core and stored here on your corporate SAN. So there's some very interesting use cases here for SteelFusion Core, but keep in mind in a collaboration environment where typically we live in the AEC space, we can utilize a combination of SteelFusion with the Steelhead WAN acceleration technology. So our proof of concept program is very simple. It is exactly what you think it would be. If you're interested in any of the technology that I've shown you today, you can do a test on your own network. We implement the solution, you run it for 30 days. At the end of the 30 days, you decide if you want to keep it, you keep it in place and we invoice you. If not, you just unplug it and send it back to us, and there's no charge for anything, including no charge for our services during that 30-day period. I kept it pretty close to 30 minutes, as I said. I'd like to remind everybody that we will be at the Autodesk University show again this year. We're in booth number 365. We're right next door to the Bluebeam booth. Bluebeam always has a huge sign that they hang from the ceiling, so if you look up and see Bluebeam, we'll be right next door to them in booth number 365. So with that, that concludes my presentation. I'd like to flip it back to Jim, our moderator, and see if we've got any questions that have been generated.
Thank you, Mark. That was a great presentation, and we do have a couple of questions from our attendees. The first question actually has to do, it deals with known limitations relative to CAD-based files. So the question is, does Riverbed have any known limitations with any CAD-based files? As an example, DWG formats had performance issues in the past, and there were no real fixes at the time other than to purchase new appliances. Can you address that question for us?
Yeah, that was approximately 8 years ago or so. What happened at that time was Autodesk changed the DWG format. I think that was released 2004. It might have been later than that, but that was not a Riverbedism. What happened was at certain intervals, AutoCAD would scramble its header, so it would look like a new file for the WAN accelerator that was in place. Riverbed just happened to own the space at that time and still today. So unfortunately, Riverbed got blamed for that, but Autodesk actually came out with a fix for that, a patch, and then later they stopped making that, or they changed their format back to the way it was. What prompted that was everybody was trying to write to that DWG format, and Autodesk got a little irritated with that. So they tried to do something cute, and it kind of screwed everything up. But that problem was alleviated a long time ago. There are certainly things that we'll want to do with the Steelheads, because every new release of Windows Server, for example, will introduce new protocols. We'll want to make sure that our Steelheads support those new protocols. A lot of times it requires a software upgrade. It's important to note that the Steelheads have to be configured for your network, not the other way around. So anytime you do any changes on your network, we need to be aware of that so we can download latest versions of software and turn on certain protocols that allow you that support. With Revit in particular, even if your Steelheads are configured 100% correctly, there are still things in Revit that we must do. The biggest thing that I find is attachments. what will happen is one user will put a drive and make attachments from that drive letter. Someone in another office won't have access to that drive letter, and when you do a sync to central, Revit will sit there and look for that drive letter that it can't find, and you'll see 15, 20, 25-minute waits. Revit will never report to you that, hey, it's this file I can't find is the problem. You'll just get really frustrated and think that the Steelheads don't support Revit, when in fact they actually do. All you have to do is to be very careful about those links or those attachments that you make to your Revit model.
Thanks, Mark. And we do have another question as it relates to Panzer. Can you expound on the differences, perhaps how Riverbed is different from Panzer?
Vastly different. Panzer's solution is to move data closer to users, where the Riverbed solution is to address latency, which is the reason why things are so slow over those connections. Because the Steelheads are not changing or overriding the Microsoft file locking system, it allows us to have support for document management systems, for example, which are very prevalent in the AEC space. Anytime you have a database-driven application, it's very difficult and oftentimes not compatible when you try to use a global file system or a system that replicates data to each office. Because we're not overriding that Microsoft operating system, I can size an appliance based on the size of the office. So for a 5-person office, for example, I've got a Steelhead appliance that's less than $3,000 that I can drop into that smaller office. The larger appliances don't function any faster than the smaller ones. They simply provide more capacity. Other things that I think Steelhead excels versus competitors, Panzer being one of those, we accelerate web traffic. So why is that a big deal? Well, if you're using Deltek's accounting software over a secure browser, we'll accelerate that traffic as well. Email will accelerate email. Well, what's about that? We don't really care how fast email comes. But if you're trying to do group calendars across a WAN, we can accelerate that. Also, email is a huge consumer of your bandwidth. So if we can reduce that use by 90 or 95% and give you back that bandwidth for use for your data, now we can oftentimes negate the need for you to have to upgrade your bandwidth for a smaller office. We also have the Steelhead Mobile client, which I think is a huge advantage to be able to work from home or work from a construction trailer and get that same kind of optimization on an individual basis. And lastly, I think another point is tooting our own horn a little bit here. We have a solution called the CSG BIM Cloud, and this is a solution that's designed as a project-based Revit model sharing solution. It's built on the Steelhead WAN acceleration technology. I don't know of any of our competitors that have a project-based solution available for the AEC space that compares with that. So those are a few examples of where I think the Riverbed technology excels over competitors. In this case, we're talking about Panzer.
Thanks, Mark. And we have another question as it relates to Riverbed and Revit. We've heard that Riverbed doesn't work with Revit. Is that true? Can you talk about that a little bit more?
It's not true. What happened was when we moved to Windows 2008 and Windows 7, Microsoft introduced new protocols, SMB 2.5 I think it was, and they didn't really tell anybody that they were doing that. That caused Revit to slow considerably. It was a simple solution. We had to join the domain or join the Steelheads to our domains, upgrade the software, turn on SMB protocol support for the later versions, and then the Steelheads were ready for Revit. I mentioned before that even if the Steelheads are 100% compatible or configured correctly, there were still things in Revit that we needed to do. I'll show you one of those things here. This makes a big deal. If you go under Revit, under Options, we have to have this work share update frequency setting. By default, it's over here to the right. We need that to be all the way to the left. What happens when this is to the right, two things really happen. When you go to manipulate an element, if this is all the way to the right-hand side, more frequent, you'll start seeing delays of 5, 6, 7 seconds before Revit allows you to manipulate that object. Also, it's constantly going back to the central file when it's set over here. Moving it, it will only check the central file when we do a sync to central. So if everybody is not adhering to this standard here, I saw an example actually. I had 2 users in a remote office once. One of them had the setting set this way. The other one had the setting all the way to the right. They called me one day. They were sitting right next to each other in the same office. One of them was doing a sync to central in about 30 seconds. The other one was taking 4 minutes, and we couldn't figure out why. This was why. Once the user moved this setting to the left, then he also got 30-second sync to central times. The big thing that we find, though, is as I mentioned before, it's those attachments. So being very disciplined about where you're making those attachments. I always say a good rule of thumb or a good best practice is to make your attachments from the server on which the Revit model resides. And if you do that, then anyone who's accessing that Revit model, of course, will have access to all of those attachments. And not doing so, you won't see it necessarily in the open times, but when you do a sync to central, that's when you'll get 20 to 30-minute wait times. You'll see corruption in your model. The application may time out on you. And it's a very simple fix. You just have to know what to do.
Thank you for that clarification. And this is our final question posed by our attendees. This actually deals with licensing. How is Steelhead Mobile licensed?
Steelhead Mobile is a concurrent license, much like if you're doing network licensing with Autodesk. It's a pool of licenses either on a virtual mobile controller or a physical controller. So you can have, for example, 10 licenses up on the virtual mobile controller and have those installed on 30 machines. The first 10 users that access the VPN will grab that mobile client, and then when you're not using that, that license returns to the pool for someone else to grab. Very common, very, very standard.
Okay, great. Thank you, Mark. That concludes the question and answer session, unless anyone has any other questions. But thank you very much for your responses to these questions and for the presentation.
Thank you. Look forward to seeing everyone at Autodesk University.